quite a bit of vocabulary in naming, so we're starting out with identifying or defining what a ray is. So we've already worked with lines and we've worked with segments. One thing I do want to mention, because as I had already started to grade your quizzes, this came up a little bit. When you are drawing a line, make sure that you do have arrows at both ends for a line. If there are points on that line, you do need to actually put dots to represent those points and label them. So say it was line AB. So I saw some labeling of lines where you would put A and B, but not actually put that the points or the dots were on the line. So make sure you put the dots on there. And if it's a line, you have to have the arrows. If you don't have the arrows, then you just have a segment, a line segment, or just a segment. So this would be segment AB if you don't have the arrows at the end. So I saw where some it might have said to draw a line, and instead you put a segment. You didn't have the arrows at the end, or you didn't have the dots on there to represent the points. So when you get those back, you'll see on yours if you know that was you. But just to get used to drawing those, sketching them, and then the notation. So a ray is part of a line, and it has one endpoint. So number of endpoints below that there is 1. And then it extends infinitely in one direction. So this here is a ray, and you might be familiar with rays already. So notice there's one endpoint, and then it extends infinitely in one direction. So there's an arrow at one end, an endpoint at the other end. So a line has 2 arrows, a segment has 2 endpoints, a ray has 1 endpoint and 1 arrow. So rays are named using the endpoint first, followed by any other point on the ray. But you have to name the endpoint first. So lines, it didn't matter which order you had the letters written in. Segments, it didn't matter which order you had the letters written in. Rays, it matters. The endpoint has to be first. So there's only 2 different ways we could name this ray, but M has to be first for both of them. So I could name it MO. And the ray symbol looks like a ray. It's kind of just like you're drawing an arrow, but you have that arrow only on one end, not on both, like you did for a line. So I could call it MO, or I could call it MP. I could not name this OP, for example, because O is not the endpoint. Or like number 2 asks, why can I not switch this and call it MP or PM? Sorry, I can't call it PM, again, because P is not the endpoint, M is. So the answer to this, P is not the endpoint of the ray. So this whole section is on angle measures. So now we're getting into angles. Angles are actually formed by rays, which is why we're talking about a ray first. So now if you choose a point on a line, this point determines exactly 2 rays, and these are called opposite rays. And then since both rays have a common endpoint, opposite rays are collinear. What does collinear mean? Same lines are on the same line. So opposite rays form a line is another way to look at this. So if I were to draw a pair of opposite rays, ray PM and ray PX, and notice they share that endpoint of P, that means I have a line because they're opposite rays. P is the endpoint of both. So then P should be in the middle of the 2 points, and then I should have M on one end and X on the other end. So that 1 point P determines 2 rays, opposite rays, and they are collinear. PM is going to the right in the way I drew it, PX is going to the left. So now getting to angles, an angle is formed by 2 non-collinear rays that have a common endpoint. And then question 4 asks, why do they need to be non-collinear? So what we just looked at is if they were collinear, so if they were opposite rays, they're forming a straight line, which they're not creating an angle like you would see here. So we could say collinear rays form a straight line. We are going to see a straight line does have an angle measure, but as we're talking about angles here, it's strictly defined that the 2 rays are non-collinear, so that it's not forming a straight line like that. So you can see that an angle has a vertex. So, we'll talk about the definitions here, but it has a vertex and then it has 2 sides, which the vertex is a point, the 2 sides are rays. So sides of an angle, like I said, are rays, and the vertex is the common endpoint of the rays. So the angle that you see here has a vertex of their common endpoint, which is point X, so it's vertex X. And then one side would be the ray XY. So XY with that ray symbol above it. And it does have to be XY, not YX, since X is the endpoint. The other side of the angle is the ray XZ. So XZ with the ray symbol above it. And now we're going to look at 4 different ways we could name that one angle. So this one angle has 4 different names. So again, as you're kind of doing your practice or even correcting it on Monday, just know I've tried to put all forms of the answer on the answer key, but if you have something written differently and just want to check if it's correct, make sure you ask. So one way you can name an angle is with the common endpoint, the vertex. So I could call this angle X. As we're going to see in examples, the only time I could call this angle X is as long as there isn't another angle that has the same vertex. So if you have multiple angles that have the same vertex, you don't just want to call it angle X because then you won't know which angle you're talking about. I could also call this angle 3. So since there's a number written inside of that angle, I could call it angle 3. You can also name an angle with 3 letters, with 3 points. When you name it with 3 points, the vertex has to be in the middle. It has to be the second letter that you write down. So I could call this angle YXZ. So angle YXZ or ZXY. But again, for both that X, that vertex has to be in the middle. Okay, and then before we get to an example, an angle divides a plane into 3 distinct parts, and those parts are what's on the angle, what is on the interior of the angle, and what is on the exterior of the angle. So that kind of shows the 3 parts here, but the angle itself is one of the 3 parts. So if we were to look at this diagram and name points that are actually on the angle, so points that are either on the vertex or on the 2 sides, the points on the angle would be Q, M, and N. Interior points of the angle, interior would be inside of the angle that's formed, and those would be points R and S, so the darker shaded region on your sheet. So R and S would be considered on the interior of that angle, leaving then points P and O, the lighter shaded region, to be considered the exterior points of the angle. Okay, are there any questions so far? I know everything so far is strictly definitions or how you write things, but are there any questions at the moment? Okay. So now looking at this set of questions for this diagram, we'll kind of look at this together here. So we have this map, and notice you can kind of see it's the map of a high school. So you can see though whether or not you have arrows or endpoints. So like up here for A, this is a line that is extending all the way up. Same with at D. E is actually an endpoint; it stops there. L has an arrow. There's an arrow going this way. There's an arrow going off of J. So you can kind of see the arrows drawn in there to see if you have lines or segments, or I should say endpoints also. So 5 says name all angles that have point B as a vertex. Can somebody give me an angle that has B as a vertex? Okay, ABD. Anybody have another name for that same angle? ABD could also be called angle 1. So angle 1 is the same as ABD. I'm just going to write it above it. And then what's another angle that has B as a vertex? CBD also. What else could we call angle CBD? Angle 2. Now realize there's more names than that also. Like I could do DBA, DBC, or there's other letters I could have used for that angle. So angle 2 actually has a lot of different names because of all of the points that you see that are on it. Okay, then it says name the sides of angle 3. So find angle 3 on your diagram. So here I'm going to help out with this one because one side, so C is the vertex of angle 3. So one side would be starting at C and extending to E. And remember, the sides would be rays or they could be segments. So CE, because E is an endpoint itself, this is just a segment, not an actual ray. So I would write CE, but just with a line and no arrows above it to represent that it's a segment. And then the other side starts at C and extends up. So I could call this 2 different names, and it does extend all the way up. This is a ray. So I could call it CB, or I could call it CA. So I could call it ray CB would be one answer. I could also call that ray, oops, I wrote the same exact thing, didn't mean to, CA. So you wouldn't have to give both answers there. I'm just giving you both ways you could write it. Seven says, what's another name for angle GHL? So when you see an angle given as named as 3 letters, what I recommend is on your sheet going to GHL. So that's my angle here. So what's another name for that angle? That's angle 7. Anybody have another way you could write that? Kelly? You could call it, if you flip those around, angle LHG would also be an acceptable answer. Anybody else have another answer? There's one other way you could name it. It just could be called angle H, because that's the only angle formed by the endpoint H. Okay, so when we look at your B the angle B, you could not refer to anything as just angle B because you have two angles that have B as a vertex. So you wouldn't know if you had angle B which one they're talking about. Angle H, though, there's only the one angle there. And that is an H, not something else. Okay. Then 8 says name a point in the interior of angle DBK. So again, I'm going to go DB and then find K. So it's this angle here. So what would be a point that's on the interior? E. So if you said C, C is actually on the angle. So interior would be, if this is my angle, this region here would be the interior. And then everything over here is the exterior. And then D, B, C, K, L are all on the angle. So the only answer for 8 is point E. That's the only point that's interior of that angle. 9 says, what's the vertex of angle 5? That is C. So if you find angle 5, the vertex of that angle is C. It's a point. 10, write another name for angle ECL. So ECL. What else could we call that angle? Angela? We could call it angle 4. Anybody have another name? For ECL, we could call it LCE. Angle LCE. Anybody else have a different name? It could be ECK. Or the flip of that, I'll write it KCE. Can we call it angle C? No, because we have actually 3 different angles that have C as a vertex. So angle C can't be used because we wouldn't know which one we're talking about. 11, name the sides of angle 5. Can somebody give me one side for angle 5? There's different ways you could write both sides. Is your hand up, Angela? No? It's okay if you say something wrong. We can all learn from something. Jasmine? So it's not just named with one point. So because the sides are... Yes, we could use GC. You want to start with the vertex, though, because you want to name this ray. So yeah, CG would be one side, and that's a ray. So I'd have CG with the ray symbol above it. You could also call that side ray CJ. That would be the same side. CJ would be the same side. So I'll put / CJ would be an alternate answer for that side. The other side then, CB or CA. And that is also a ray. So the vertex is a point. The sides of an angle are rays, or they could be segments. And then 12, name a point in the exterior of angle CLH. So find CL and then H, so it's this angle. So what's a point, and actually this extends all the way up. So what's a point that is exterior? E or D is also exterior of that angle. Okay, so even in those questions, it's naming angles. It's being able, if you're given the name of an angle, to determine what angle they're talking about. And there's a lot of vocabulary in there as well. Sides, vertex, interior, exterior. Any questions on 5 through 12? Okay, so then this is on measuring angles, and you do have only 3 questions on your assignment that would have you use a protractor. So I do have some in class because you're not required to have your own. So if we don't have enough time for you to do that part of your assignment while you're in class today, we'll either do it Monday, and I'll have you do something else with those 3 questions. But just so you know how to use a protractor, this kind of outlines it for you and you'd have a chance to practice on your assignment. Angles, first of all, are measured in units called degrees. That is the common measurement we use in geometry is degrees. And the degree results from dividing the distance around a circle into 360 parts. So what this means is that if you go all the way around a circle, there are 360 degrees in a circle. And then the tool used to measure an angle is called a protractor. And that is this thing, this half circle thing that you see on your sheet. And it tells you how to use a protractor. So when you're using a protractor, you want to, I'm looking in the lower left here, that lower left box, you place the center of the protractor on the vertex of the angle. So we're looking at angle FED here. So place the center of the protractor on the vertex of the angle. The protractor does have 2 scales from 0 to 180. So it goes from 0 to 180. We're going to talk about this below. If there's 360 degrees in a circle, half of 360 is 180, meaning there's 180 degrees in half of a circle. So that's why it goes from 0 to 180. And it goes in opposite directions. So you'll see like this side, the bottom, 0 starts here and it goes to 180 this way. If we go the other way, this side starts at 0 and goes to 180 the other way. So you align the 0 on either side of the scale with one side of the angle. So you want the center of the protractor at the vertex, and then you want it lined up with one of your 2 rays. And then you look to see where the other ray meets. So it's from 0 to, this one is aligned at 50 degrees. You can see it. And that means, I would write this as the measure of angle, I'm going to call it DEF, is 50 degrees. So just like there's different symbols or different ways to write a segment versus the measure of a segment, if you just see an angle symbol, it's talking about the name of an angle. If you are talking about the degree measure of an angle, you should have an M in front of that angle symbol. This is the measure of angle DEF is 50 degrees. So when you see that M, that's what that means. Okay, so then moving on then to classifying angles. So this is how do you know if you have a right angle, acute angle, or obtuse angle. We also are going to talk about straight angles. What measure do right angles have? 90. 90 degrees. So a right angle, you never assume that an angle is a right angle unless it tells you in the problem or you see this little box in a corner that tells you it's 90 degrees. So, for example, if I call this, I'll put an A here. I could say the measure of angle A is equal to 90 degrees. So don't just say angle A equals 90 degrees. You need to have the M in front. What do you know about acute angles? They're less than 90. So acute angle measure is between 0 and 90. And you could add degree symbols on those numbers too. So here I'll try to draw where the 90 degree angle would be and then show an acute angle would be less than that. That means obtuse angles are greater than 90, but specifically the measure is between 90 degrees and 180 degrees. So again, I'll show where the 90 degree angle would be, and then an obtuse would be larger than that. And a straight angle, so this is an angle that forms a line. So it would just look like a line. You might see a point that would be the vertex of the angle, but the angle is a line. Straight angles have a measure of 180 degrees. So if I called this, say, this is point B, I would say the measure of angle B is 180 degrees. So you might be asked to classify angles. If you are ever asked in directions to classify angles, this is what they mean. They want you to say, is it a right angle, acute angle, obtuse angle, straight angle? Okay, and now we're going to move on to congruent angles, angle bisectors, so those definitions and then some examples. So I know a lot of this is not really examples, it's a lot of notation and vocabulary. So just as segments that have the same measure are congruent segments, angles that have the same measure are congruent angles. So I did copy this figure here. So in the figure since, notice they have two angles labeled as being 65 degrees. So how would you name this angle down here lower left that's 65 degrees? What could I name that angle? Can somebody give me a name for that angle? Not sure, or just don't want to talk. Could I call it angle B? I see some no's. I have two angles that have a vertex of B, so I can't call it angle B. So what could I call it? This one here. I could call it angle ABC or CBA. So I'm going to say since the measure of angle ABC is equal to the measure of angle, what could I call this other one that's 65 degrees? DEF. Okay, so since those measures are equal, they both equal 65 degrees, I can then say the angles are congruent. So I can say angle ABC is congruent to angle DEF. So notice when the equal sign is used versus when the congruent symbol is used. You say that measures of angles are equal, and that means their angles are congruent. But you would never say measures are congruent or that just angles are equal. I know that's notation, it's very specific. And then it says matching numbers of arcs on a figure also indicate congruent angles. So matching numbers of dashes on segments indicated congruent segments. Matching numbers of arcs indicate congruent angles. So you can see ABC and DEF both had one arc to represent they were congruent. So then I can also say these two angles with the two arcs are congruent. What could I name this one here? What's a name for that angle? I heard CBE, so I can say angle CBE is congruent to, what about the other one? DEB. And know that both of those angles, there's other ways you could write those names too, because you have other points that you could use to name them. Okay, and then the last fill in the blank before we go through these examples, array that divides an angle into two congruent angles is called an angle bisector. So remember, anything that is a bisector means it cuts something in half. So a ray that would divide an angle in half is called an angle bisector. If you divide a segment in half, it's a segment bisector. So we are given this figure for 13 through 16 and told in the figure, ray QP and ray QR are opposite rays. You can see they form a line. QS bisects angle PQT. So actually, I'm going to skip to 14. It says, what can you conclude if QS bisects PQT? It means that these two angles are congruent. So it means angle PQS is congruent to angle SQT or TQS, if you wanted to name it that way. So that's what it's looking for when it says, what can you conclude if? So knowing that those two angles would be the same measure is important. If I go back up to 13, it says, or I'm trying to find the measure of angle PQR. So if I look, PQR is this straight line. So what's the measure of that angle? 180. 180 degrees. Okay, so then 15 and 16 now, like we had for segments where you may have had to set up an equation to answer the question. That's what 15 and 16 are asking you for. And you want to make sure you pay close attention to what you have. So sometimes it might help for you to highlight things. Again, if you're more visual that way, to pick out what you have. So I have a measure of angle PQT. So PQT, I'm going to try to highlight here. PQT is this pink angle. And I know that's 40. And then I also have PQS. That measure is 5x plus 15. So PQS is that angle in green. And then it says, find the value of x. So I just want to ask this. What's the relationship between PQS, my green angle, and PQT, my pink angle? What's the relationship in their measures? Yes, PQS is half of PQT. So I'm going to write that down. The measure of PQS equals half of the measure of PQT. So knowing that, I can then form an equation with the information I have. I know PQS, that's 5x plus 15. And that's going to be half of the measure of PQT, which is 40. So it's going to be half of 40. And now I have an equation I can solve for x. So first of all, what is half of 40? 20. So then I know 5x plus 15 plus u must equal 20. What would I do next to solve for x in this equation? Next step, subtract 15. So 5x equals 20 minus 15, which is 5. Divide by 5. 5 divided by 5 is 1. So x is 1. And it said find the value of x. Make sure you go back to the problem and see if it's looking for something else. You might need to substitute it back in somewhere. Okay. Then 16 is working with the same diagram, but is not related to your answer for number 15. So it says if measure of angle PQS, so that was the angle I highlighted in green. So now that measure is 2x plus 10. And then I have the measure of SQT. So I'm going to need a different color here. I'll highlight that one in purple. SQT is 4x plus 6. Then it says find the measure of angle PQT. But in order to find that, I need to know what x is. So Looking at how I highlighted it, what's the relationship between these two angles and their measures? They're the same. They're equal. So I know the measure of angle PQS is equal to the measure of angle SQT. Okay, so that means PQS is 2x plus 10. That must equal SQT, which is 4x plus 6. And again, I now have an equation I can solve to find x. So what I could do first is I like to keep the x term positive if I can. So I would subtract 2x from both sides. That's not the step you'd have to do first. So I still have 10 equals 4x minus 2x is 2x. I still have plus 6. Then I would have to subtract 6 from both sides next. 10 minus 6 is 4 equals, I still have 2x on the other side. Divide by 2. 4 divided by 2 is 2. That equals x. So again, don't circle x as your answer. This question doesn't want to know what x is. It wants to know what measure of angle PQT is. So looking at PQT, that's the entire angle. So I would have to substitute x back into at least one of these. And this is a way that you could check your answer as well. Knowing that these two should be the same, if I plug x into both of them, I should get the same number when I plug x in. If you don't, that means your x value is wrong. So if I plug it into PQS, I have 2 times 2 plus 10. So that's 4 plus 10, that's 14. That means if I plug this in to angle SQT, I should also get 14. And if I don't, that's a problem. So that's 4 times 2 plus 6. So 8 plus 6, that is also 14. And then I'm looking for PQT, which is those two angles together. So measure of angle PQT would be 14 plus 14, which is 28. Okay, so there are ways for you to check in some cases, check to see if you're going